Let's quickly take this up. First of all, the first step is degree. And degree is 6, 8, 9, right? Once you know that the graph is going like this. Degree 3 to 1. And then second step, don't worry about the graph yet. Just plot it. So we have -5. We have -3. Maybe -3 will be about there. And -1. And +4. Just plot it. Put circles on it. Put dots on it. I know I have to start from here. Okay, I have to finish up here. Okay, now we have to fill in between. Okay, so actually no other graph you can just fill it in like this. This polynomial is beautiful in this way. You know the general behavior, you know this, and you can just draw an approximate picture already. Okay, so this is degree 2. That means we're gonna bounce. This one is degree 1, so we have to pass right through. Come back down. What's this one? Degree 2. So we gotta bounce again. And how high does it go up? You can find the y-intercept by plugging in 0. I'm not gonna do that in this example. I'm gonna just assume that it goes up pretty high though. So go a little bit high. And power of 4 is also a bounce. And do you see that if it doesn't bounce, actually it wouldn't be an all power polynomial? Yes, so it has to bounce. It makes sense to bounce. Okay, I mean, yeah. So some teachers care a little bit about how high this goes up, but you really can't calculate it. Like if they want you to plot it more carefully, you have to use your calculator and plug in some random value in between -3 and -1 and see how high it goes up. Another important thing is the local max, the number of local max and minimum. How many local max do we have? So number of local max. 1, 2, 3,
4.
Local.
Isn't that local?
This right here? No, this is not. This is, it goes up forever.
Just the max. Oh.
Local, so there's 3 here, right?
Yep.
What about local minimum?
3.
1, 2, 3. Okay. Now, we have a degree 9. We got a 6. Okay, 6 local max and minimums, right? So, what is this? Like, do we always get 6? How many do we get? Right. Let's say we have a degree of polynomial, and we have, let's say, n. How many local max and minimum are we gonna get? How many? Local max or minimum. Okay, let me just draw an example here. Let's say I can have an example like this. Let's say x minus 1, x minus 2, x minus 3, x minus 4. This is a degree 4, right? With absolutely no multiplicity. 1, 2, 3, 4. Just gonna draw it approximately. All I care right now. Oops. What did I do wrong? I have to start from the top, but I start from the bottom, right? Degree 4 starts from the top. 1, 2, 3, 4. So how many local max do I have?
1.
How many local minimum?
2.
So I have degree 4, and let's call this big N, okay? And I got 3, right? Is it possible to get more than 3? There's no way, okay? But is it possible to get less than 3? Yes. So we say this, okay? We say this, right? If the degree of polynomial is n, then number of local max or minimum is less than or equal to n minus 1.
Oh, yeah.
Okay, n minus 1. So if it was 3, right, it's at most 2. At most 2. If it's 10, it's at most 9. Okay, so how do we get rid of this local max minimum? Here's an example. Right? Let's do an example way here. How do we shrink the number of local max minimum? Let's say you have x minus 1 and x to the power of 2. This is degree 3 also, right? So let's see what happens. What disappear? 0, 1. This is like this, right? How many local max or minimum do we have here? We still have 2 actually. Actually, the bounds does not destroy the local max minimum. I guess we have to do something like this. X to the power of, this is degree 3, right? How many local max minimums does that have? Yeah, none. It destroys all the local max minimum. Maybe a better example would be, let's say we have this. X minus 1 to the power of 3 times by x. Let me just draw a rough picture here. Degree 4, so look, it's gonna do this, right? Pass through and do this. How many local max minimum do we have here? 1. But if it was a typical non-multiplicity degree 4, it'll look like this. 1, 2, 3. Okay, so this power of 3 gets rid of some of the local max or minimum. Does that make sense? Okay. But ultimately, they want you to usually draw it and tell me exactly how many local maximum minimum there are.